Extractive metallurgy is the practice of removing valuable metals from an ore and refining the extracted raw metals into a purer form. Extractive metallurgists are interested in three primary streams: the feed, concentrate, and tailing. It takes multiple steps to extract the important elements from the ore. First, the ore must be separated from the unwanted rocks. Then the mineral needs to be separated from the ore. Further separation method is required since most minerals are not pure metals. These steps are widely known as the beneficiation process or mineral dressing. Welcome to James Sword Research Channel. In this video, we will look at the beneficiation process of ore in detail. Watch the video till the end for better understanding, and if you find the video useful, like and share the video. Subscribe to the channel and turn on the notification icon for more content. What is the beneficiation process? The beneficiation process is a process that removes the gangue mineral from the ore, in order to produce a concentrate containing the essential mineral. It is the science of extracting metal from their ores. The beneficiation process is the first process most ore undergoes after leaving the mine. The process is also known as mineral dressing, ore preparation, ore milling, ore dressing, etc. The beneficiation process may involve physical or chemical processes. Since most of the ore minerals are intimately associated with gangue minerals, the various minerals must be broken apart before they can be collected in separate products. Definition of the major terms used in the beneficiation process. Ore. These are the aggregates of the rocks from which the desired minerals are extracted. Gangue. These are the impurities, sand, mud, rock substances, etc., present in the ore. Concentrate is the enriched portion containing the essential mineral from the respective ore. Steps in the beneficiation process. The process of mineral beneficiation involves several steps to enhance its quality and remove impurities. The typical steps of mineral beneficiation are as follows: 1. Comminution. 2. Sizing. 3. Concentration. 4. Dewatering. 1. Comminution. The first stage in any ore beneficiation process is comminution. Comminution is the process of reducing the particle size of the ore to a finer state or powder. Comminution is made on dry material or slurries to reduce their sizes. It involves either the crushing or grinding of the ores. Therefore, the crushing and grinding of the ore is known by a common name called comminution. Crushing and grinding are slightly different, as crushing involves a drying process while grinding is a wet process. Crushing. The purpose of crushing is to prepare the ore for beneficiation. In the early stage of development, crushers were small hand-operated pestles and mortars. Today, this process is carried out in mechanized crushers and mills. To produce a crushed ore suitable for use in mill feed, crushing is done in stages. They are primary crushing, secondary crushing, and tertiary crushing. Primary crushing, also known as coarse crushing, reduces the ore to a size that can be handled by a secondary crusher. In the primary crushing, the ore is crushed down to about 10 centimeters. Jaw, gyratory, and impact crusher are the ideal primary crusher. Secondary crushing or intermediate crushing. In this stage, the ore is crushed from 10 centimeters to less than 2 centimeters in size. Cone crushers are often placed in a secondary crushing station because they are versatile in terms of feed and discharge. In tertiary crushing, also called fine crushing, the ore is crushed from 2 centimeters to less than 0.5 centimeters. A cone crusher, vertical shaft impactors, or even a high-pressure grinding roll crusher can be used in this stage. Grinding. Grinding is a wet operation that requires water to make a slurry. In this process stage, the crushed ore is further disintegrated in a mill. In primitive times, the grinding was done by millstone turned by men or water power. Presently, it is carried out in a roll mill or a ball mill. The crushed ore around 0.5 centimeters in size is fed to the grinding mill. The mill grinds and produces ore which is less than 0.01 micrometers in size. After the comminution, crushing and grinding, the next step is sizing. 2. Sizing. Sizing is the process of separating the particles based on their size. The sizing consists of two procedures: screening and classification. Screening is carried out on relatively coarse ore. It involves introducing the ground ore to the screen surface and allowing the finer ores to fall through the screen, while the bigger ores remain behind. The equipment used for screening includes a bar screen, flip-flop screen, vibratory screen, etc. Classification, on the other hand, is a method of sizing mineral particles based on their settling velocities. In classification, particles with different sizes but the same density will settle within a given fluid at different rates. Classification equipment includes ore sorters, hydraulic classifiers, mechanical classifiers, cyclones, etc. 3. Concentration. Concentration involves the separation of a valuable mineral from other raw materials received from the grinding mills. It is defined as increasing the percentage of the desired mineral in a given ore. Concentration is usually accomplished by utilizing some specific difference in physical or chemical properties of the metal and gangue compound in the ore. These properties can be density, gravity separation, electric conductivity, electrostatic separation, color, optical separation, magnetic separation, and physiochemical, froth flotation separation. Gravity separation. The gravity separation method, also known as hydraulic washing, is used for metals that are heavier than the gangue particles. It uses the difference in the density of minerals as the concentrating agent. Gravity concentration is one of the oldest techniques used in the separation of minerals. In this method, water is used to enrich the ore. The ore is passed through a stream pushing up all the lighter particles, which is the gangue, while the concentrates that are heavier than the gangue settle down as they cannot be pushed. The gravity separation method is mostly used for concentrating tin and lead oxides from the ores. Examples of gravity concentrating methods are sink and float separation, also known as heavy media separation, shaking tables, jigging process, etc. Electrostatic separation. Electrostatic separation is a process that uses an electric field to separate minerals based on their electrical conductivity and charge. When mineral particles of different polarity are brought into the electrical field, they deflect in different directions in the field and can be caught up separately. Electrostatic separation is most beneficial in separating mineral sand. Optical separation. This separation process is dependent on the optical and radioactive properties of the minerals. It is a process used for the concentration of particles that have sufficiently different colors to be detected by the naked eye, or through electro-optic detectors that collect data on the response of minerals when exposed to infrared, ultraviolet light, and gamma radiation. Magnetic separation. The process involves separation using a magnetic force. The separation is based on the different magnetic properties of the minerals. Magnetized equipment, such as magnet-equipped rollers, is used for separating unwanted particles to enrich the ore. Any susceptible magnetic substance attracts the magnet and sticks to the rollers while the unwanted particles slide off. Froth flotation separation. Froth flotation is the most widely used method for the concentration of fine-grained minerals. The process involves the separation of hydrophobic particles, mixtures that repel water, from hydrophilic particles, mixtures that attract water. In the flotation process, the desired minerals are separated by inducing them to accumulate over the froth layer. The ores are added to water that forms suspension, to which collectors such as pine oil, fatty acid, and froth stabilizers are added. The collectors boost the metal particles of the ore's non-wettability, making the powdered ore form a froth on the water surface. Froth stabilizers keep the froth forming, while the water lubricates the impure particles and oil lubricates the metal. The suspension needs to be constantly stirred with the help of agitators for the froth to keep forming. Flotation makes possible the processing of complex intergrown ores containing copper, lead, zinc, and pyrite into separate concentrate and tailings. Dewatering. Concentrates and tailing produced are dewatered to convert the pulps to a transportable state. In conclusion, the beneficiation process will help improve the concentration of the ore and remove impurities. The result will be high-quality fine ore powders.